All right, guys, last one for the related rate section, okay, and for your work today, okay, there's lots, but it's probably best to see all these kinds of questions before having to do them on your own, right? So, um, this is a familiar question, okay? This is like, if you guys remember similar triangles in grade 10, right, where we set up ratios, right? That's what one of these questions is. This is how we're going to set up this question, right? So, a man 2 meters tall, walks away from a lamppost whose light is 5 meters above the ground. If he walks at a speed of 1.5 meters per second, at what rate is his shadow growing when he is 10 meters from the lamppost? Okay, so just like in grade 10 when we saw these questions for the very first time, I'd say let's draw a little diagram here, triangle. Right, we're going to have our lamp over here on the left. It's not going to connect it for me. Nice picture. Okay, so here's our lamp. It gives off some light here, right? We know that the lamp is 5 meters above the ground, right? So we know from here to here is 5 meters. And then we know, the man's walking away from the lamp, and we know that he is 2 meters tall, right? From here to here, let's say. Okay. And is that about it? So at what rate is the shadow growing when he is 10 meters from the lamppost? Okay, well, we could call this 10 meters. I mean, the picture's not that great, but we'll find out in a minute. Okay, so let's evaluate what's gone on here. Okay. We could label this here X and Y, right? And so if you look at this triangle very closely, here's what we're going to have. We're going to have a big triangle, right? One that represents the outside of the perimeter of the big triangle. And then we're going to have a triangle here as well. And this is how we're going to set up our ratio, okay? And then once we set up the ratio and we do some derivative work, we can extrapolate from the question and figure out where some of the information is going to go into the question, okay? So here's what we're going to do. We're going to write out a ratio here. So we're going to say, okay, the height of this triangle relative to its base, I suppose, of the red triangle, the big one, would be 5 over x plus y. And that is going to have to equal, okay, 2 over y. And so if I were to cross multiply here, okay, we could say, okay, well, 5y is going to equal 2x plus y. Right? We could do the distribution on that. 5y is going to equal 2x plus 2y. Right? And then we can clean it up. Right? We're going to see that's okay. Well, 3y is equal to 2x. Okay? Now, if we are interested in the rate, like you'll notice here, y would be the man's shadow, right? Like it's being casted onto the ground here, right? So that's y. Y is his shadow. The rate at which it grows would be dy dx, or sorry, dy dt. Okay, so if I were to derive this rate equation implicitly, right, with respect to time, we're going to see some stuff happening here. Okay, we're going to see the derivative of 3y is going to be 3 dy by dt. Okay. And then we're going to see that has to equal 2 dy dx. Okay. Now, this here represents the rate at which the man is walking. Okay, how quickly he's walking. It's 1.5 meters per second. Okay, so that's going to be dy by dx. Okay, so we're going to see that 3 dy by dt, this is what I'm interested in, is the growth of his shadow. That's going to equal 2 times 1.5 meters per second, right? That's the rate at which the shadow is growing. Or sorry, the rate at which he is... Sorry guys, sorry. I wrote something wrong and I confused myself. dx by dt, sorry. dx by dt is the rate at which this is growing, or how fast he's walking away from the lamppost, right? dx dt. And so the rate at which the shadow is going to grow in response to that is going to be 2 times 1.5 over the 3. Okay, and we're going to see that dt, dy by dt, is going to equal 1 meter every second. What's interesting about this question, the way we've set it up, because of the ratios, right? It's actually irrelevant how far away he is from the lamppost. Okay, this doesn't play a role here. Okay, and we know that's the case because there's no more variables left here, right? It's just the two rates after we derive implicitly. Okay, so that's it. His shadow. You gotta always remember too, like when you guys get an answer, to try and contextualize it to make sure that it makes sense, right? So his shadow is growing at a rate 1 meter per second. Okay, so that's it, guys. All right, that's related rates. I'd say the stuff in the middle there with the cones and the troughs, that's probably as hard as it's going to get. And again, don't worry about the hemispheres, okay? So that's that, okay? Keep an eye for next week. We'll have a third summative. It will incorporate the stuff that we do tomorrow and Monday, along with everything else that we've done over the last week, okay? Around higher order derivatives and curve sketching and related rates and optimization, all that stuff, plus with related rates. Tomorrow, we will do some derivatives on exponentials and log functions. And on Monday, we'll do some ln and the trigonometric functions as well. Okay, so we'll do the derivatives of those, and that'll wrap up the calculus portion of this course. We'll probably have a test midweek, and then the vector test will be on Monday next week. Okay, so that's it, guys. We will see you tomorrow for the exponential lessons. Okay.